In this video, we're going to talk about how to balance reactions. So balancing reactions is all about keeping track of your atoms. And when we go through and we balance a reaction, we have to make sure that we first identify our products and reactants appropriately. So in this example, I'm going to have phosphoric acid react with barium hydroxide. And this is an acid-base reaction. And so we must first predict our products. Well, acid-base reactions, like many, follow the double replacement reaction in that cations and anions exchange, with the only caveat being that one of the products in an acid-base reaction is always water. So when we look at what's actually making up these cations and anions, we know that we have H pluses in phosphoric acid, and we also have the phosphate ion in phosphoric acid. Barium hydroxide, well, barium is a +2 cation, and we have hydroxides, which are -1 polyatomics. So what we need to do is assemble our new product molecules. Well, hydrogen's going to pair up with hydroxide, and that's going to make HOH, or H2O, which we know is a liquid. And then we're going to pair up the barium and the phosphate to make barium phosphate. Now, one little trick you can do to make sure you get the right formula is you can see the 3 here and the 2 here. Well, oftentimes you can just crisscross those and make those the coefficients. So barium would become 3 and phosphate would become 2. Well, if you look at what I just wrote, the 2 after the phosphate, you can see it looks like it's PO42. So anytime you need more than one polyatomic ion, remember, you have to put it in parentheses. So now we've got our proper formula, barium, phosphate, and water as our products. So next, to balance the equation, what we're going to do, is make a little column, because if you look at the equation right now, what you'll see is, is that this reaction is not balanced. And I apologize. So what we're going to do is we're going to make a little table. Okay. We have our reactants and we have our products, and we're going to count. Now, I've got hydrogen as a cation, I've got barium as a cation, and then since my 2 anions are polyatomic ions, what I'm going to do is I'm just going to write them as polyatomics, because the polyatomic ion didn't actually break during the course of this reaction. So now what we do is we start counting up, and I always say start with the simplest one first. So we've got hydrogen, barium, oxygen, or hydroxide, and phosphate. So what we can do is pick any of these to start with. I'm going to start with barium, and the reason is that I can see already on the right hand side I need 3 bariums for my products. So that means I'm going to need 3 bariums as reactants, and to do that I'm going to put a 3 in front of the barium hydroxide, making that a 3. Well, by putting a 3 here, that means I've got 3 bariums, but I've also got 6 hydroxides. So I know I need to have 6 OH on the left-hand side, which means I need to have 6 OH on the right. Now, water's a little tricky, but we can get around it by remembering water is H2O or HOH. Now, don't write HOH, that's wrong, but in terms of visualizing where the hydroxides are, we can now see and distinguish the hydrogen ion from the hydroxide ion. So what we're going to do is we're going to put 6 in front of HOH, and that gets us our hydroxides balanced. Well, by doing so, I also made 6 hydrogen ions, which means I need to have 6 hydrogen ions on the left-hand side. Well, going back to the reactants, we can see hydrogen comes in sets of 3 here. So to get to 6, I need to multiply this by 2, and now I have 6 hydrogens. Finally, with 2 phosphoric acids, that means I also have 2 phosphates. And if we look over at our product side, we've got 2 phosphates over there. So we have a balanced equation. So these tables help us track through our atoms and our polyatomic ions and making sure that nothing is forgotten during the course of a reaction. So that's how to balance an overall chemical equation. Next, what I'm going to do is I'm going to show you how to take a total ionic or total equation and change it into a total ionic equation. And so go there, put that 6 back there. So when you write a total ionic equation, what you do is you represent everything that's an ion as an ion, and you keep together solids and liquids. So phosphoric acid, we know that's aqueous. We can use our solubility rules to look at that. Barium hydroxide's aqueous, H2O is a liquid, and barium phosphate we'll say is a solid. So we need to deconstruct all the aqueous materials. So the first thing we have is our hydrogen ion. And since we have a 2 in combination with the 3 here, that means we have 6 hydrogen ions. Those are aqueous. And to that, we also have phosphate ions. And we always need to write the charge. And because there's a 2 here, that gets distributed into both cation and anion. So we have 2 phosphate. Let's move over to the barium. So we've got 3 barium ions. And again, we have a coefficient which we need to distribute. So 3 and that 2, that makes it 6 hydroxides, also aqueous. Over on the product side, we see we've got water. So 6H2O, liquid. We're not breaking that up because it is a liquid. We don't break up solids, liquids, or gases. And that also means in this case, we're not going to break up the barium phosphate because it is a solid. And that would be the total and net ionic equation for this particular reaction.